So, now we come back to the proof. In the proof, I said that I will prove by induction. Induction what? This is the relation that at any index n, we have to show that VIN is an advanced version of UIN. That is, UIN is a delayed version of VI. Conversely, if VIN is an advanced version, that is, VIN is nothing but UIN plus some amount R of I. R of I is the retiming value of ith naught, which is known to you. I have to prove this. I said I will prove by induction. By that I mean, I will assume that this relation is true for all n less than some index n naught. That is, if it is n naught minus 1, fine. If it is n naught minus 2, fine. If it is n naught minus 3, fine, dot, 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 it is true. Under that condition, I will show it is true for n equal to n naught also, and then it will continue. So, I repeat, I will assume this to be true for all n less than n naught. N naught is some index. Okay, that is n naught minus 1, true. N naught minus 2, it is true. N naught minus 3, it is true. Then I will show it is true for n equal to n naught also. Okay. At one case I will show directly, that is very silly, that is simple. Now, here what is UIN? I will go to a new page, so just take a look, because there the diagram will not be there. UIN will be nothing but something similar, because the node has not changed, so it will be function UIN will be like VIN, UIN function Fi, instead of V1 it will be U1, but the delay will change. Earlier I had AI1, so AI1 has been changed to AI1 plus R of I minus R of 1. Aij has been changed to Aij plus R of I minus R of j, dot, dot, dot. Only delay values will be changed. V1 will be replaced by U1, because the new circuit has no V, only U's. Vj has Uj, Vi will be replaced by Ui, dot, dot, dot. X will be as it is. Bi will be replaced by, here it is Bi, it is Bi plus Ri. So, Bi will be replaced by Bi plus Ri. So, that will give you UIN. I will take a special case n naught, Ui n naught, and I will show that is equal to, I mean, if it is Ui n naught, then Ui n naught plus Ri will be equal to Vi n naught. So, this relation will be valid at n equal to n naught also. Okay. And remember, every node is basically a function of all other nodes and itself, but their past values only. Even if the delay is shown to be 0, effectively it turns out that every node depends on the past value of all the nodes. Okay. So, just for your convenience, I rewrite here, I had VIN was Fi, just for your convenience, so that you do not have to refer to that page. It was V1 n minus I, destination I 1 dot 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 Vj n minus Ij dot 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 V capital N this was VIN, UIN, UI. Suppose I take n to be n naught, it will be Fi, instead of V1 it will be, as I told you, U1, n is replaced by n naught, because a particular n I am taking, minus the delay. Delay now is not AI1, it will be AI1 plus R of I minus R of 1 dot dot dot. I will not write all the terms, just general term Uj would be enough, n naught minus Aij plus dot 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 x n naught minus Bi and then there was another term R of I. Okay. So, Ui n naught is such, the advanced version Ui n naught if n naught is replaced by n naught plus r I, the retiming value of node I, r of I is brought in. So, replace n naught by n naught plus r I. So, if you have n naught plus r I here, that r I will cancel with minus r I. Here also r I will cancel with r I, there is a minus sign everywhere. Okay, n naught here, n naught plus r I will cancel with this r I. Well, r of I is comes with minus sign in all the expressions. Okay. So, we will be left with u1 remaining one. Remaining part I write this way. I put n naught minus ai1, n naught minus ai1 in a bracket, r I is already cancelled out, and minus minus plus of r1. Okay. Dot 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 uj, again n naught minus aij, yeah, this is okay, I can make it like this, plus r j minus minus plus r j dot dot dot, and lastly r I is gone. So, simply x n naught minus b I, this one. But now I assume use the induction hypothesis. Come here, ai1, suppose ai1, the delay between node 1 to node I, okay, original circuit, original DMG before retiming, there was a single delay only ai1 in the path from or in the edge from node 1 to node I. Suppose ai1 is not 0, it is positive. It could be either 0 or positive, suppose it is positive. If this is positive, then this is, if you call n equal to, if you call this n say n naught minus ai1, since this is positive, the whole thing is less than, I mean is less than n naught. So, n is less than n naught. So, I have got u1 n plus r1 by my induction assumption. For any n less than n naught, the relation is valid, that is u1 n plus r1, that is if the u output, node 1 output after retiming is advanced by r1, this will be same as original V1 at that index n. This is what we are trying to prove. Our assumption was that this is true, whatever we are trying to prove, this is true for all n less than n naught, that is up to n naught minus 1, n naught minus 2, n naught minus 3, and so and so, okay, but not at n naught. But if this is positive, then this whole index n is obviously less than n naught. So, I can use my induction hypothesis. So, n plus r1, that is u1 index n and advanced by r of 1, retiming value of node 1, that by that assumption will be nothing but original V1 at n. Okay, that is at that point. Similarly, assume that this delay, all the delays are positive, this aij also positive. Okay, so, n naught minus aij, if you call that to be n, so again by the same token uj n plus r of j, n is here n naught minus aij, suppose aij also positive. So, n is less than n naught. So, again my assumption works, induction assumption uj n plus rj, that is advanced by rj, that will be same as vj at n, and n means here what is n? I replace n by what I took. Dot 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 dot. So, if all these delays are strictly positive, then obviously I have got this turns out to be f I V1 n naught minus ai1, V1 n is sub n naught minus ai1 dot 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 Vj n naught minus aij, n naught minus aij, okay, x n naught minus b I, x n naught minus b I, it is nothing but this turns out to be equal to v I n naught. If you put n naught here, f I v 1 n naught minus a I 1, n naught minus a I 1, v j n naught minus a I j, n naught minus a I j, dot 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 x n naught minus b I, x already n naught minus b I. Okay. So, this relation is valid at n equal to n naught also, that is u I, if from n naught it is advanced by r I, u I of that will be same as v I at n naught only. So, the relationship continues at n naught, but this also that proves the validity of the induction, but this assumes that these delays are positive, strictly positive, not 0, at least 1, 2, 3, so that n is less than n naught, not equal to n naught is. Then you can ask me a question, what about those DFGs where suppose a I 1 is 0, if a I 1 is 0, n and n naught are same, so it is not less than, it is equal to, so you cannot use the induction hypothesis, because induction hypothesis says that for n less than n naught, the relationship which I try to prove is valid, this is valid. But if n is n naught, then I cannot say that this equal to this. If n is less than n naught, then u 1 n plus r 1 will be v 1 n. But if n is equal to n naught, then what happens? Then I tell you, the moment I come across this that okay, the a I 1 is 0 in my original expression, okay, what I do is this, I will have u, I mean in the original expression it will be u I n, from here only you can say u I n equal to, suppose in the original expression, suppose v I n equal to f I, okay, you start back with v I n f I v 1 n only, no delay. If a I 1 is 0, it will be v 1 n only. The moment I get v 1 n, I will replace it, okay, or say start with v j because it is a self loop, okay, v 1 n, suppose fine, v I n is a function of suppose v 1 n only, no a I 1. The moment I come across this, I will replace v 1 n by its own function. I told you an example of 3 nodes. The moment I come across a term here inside with no delay, I will replace it by its own function. So, function within a function. And this way if I proceed, finally, I will get a huge expression where all the terms will be strictly delayed, right. No 0 delay term like a I 1 0 or a will come there, okay. All strictly delayed terms will come, okay. And therefore, this will not come up that okay, I mean what happens if the particular delay is 0, because the moment I have say a I 1 0, v 1 will be replaced by f 1 something and so on and so forth. So, you will have f I, then within that f 1, maybe f 2, maybe within f 1, f 2, within that f 3, so on. So, a huge nested expression, and eventually all the terms will be strictly delayed. Okay. Strictly delayed means with n, there will be a positive term, n minus a positive term, strictly delayed term. Okay. Like as I told you here, okay, even if there is delay v 2 n, v 3 n, the moment I get v 2 n, I replace v 2 n by this function. Within the function I get v 3 n, no delay, replaced by the function. Then v 2 n itself, v 3 n I replace by the function. So, eventually v 1 n will be a function, within that another function, within that other, but all terms will be strictly delayed. This is positive, this is positive, okay. So, that situation will not arise, okay, because I will then work on these delayed terms. If it is n is n naught, so n naught minus a delay which is constant, which is positive. So, overall is less than n naught. So, induction hypothesis will work, okay, and I retrace my path back and I get the relation, understood. So, this shows that u I, this relation is valid here also. Earlier we said that it is valid for all n less than n naught. Then if you put such an n, so u I n plus r I equal to v I n, then when n equal to n naught, now it is shown this is also valid, and therefore, it is valid for n naught plus 1, n naught plus 2, etc. But now I have to show a direct case, that at least one direct case where left hand side equal to right hand side, that is very easy. On one hand, I have got network DFG 1 another DFG2, DFG1 before retiming, DFG2 before after retiming. Suppose these are time axis for V any node VIN, and this is the time axis for the same node, but for UIN, these are time origin. Okay. I assume that left for all n less than 0, this DFG it is cleared, that is it is at rest, that is all the node outputs are 0, 0, 0, 0, 0, 0, 0, 0. Here also all the node outputs are 0. Therefore, you can assume you take an index n, okay, maybe n naught. You take an index n naught and go here n naught plus r of I. Make sure n naught is sufficiently negative, so that n naught plus r I also to the left of origin. Here V I at this n naught is 0, U I at this n naught plus r I 0. So, this is equal to this. So, this is a case where I can directly show that V I n naught equal to U I V I n naught, which is 0, is U I n naught plus R I, because both the systems are cleared. Original system cleared, and so this is 0 at n naught, this is cleared, so that n naught plus R I also 0. So, 0 equal to 0, it is satisfied. Now, this is not just for theory, it is important that both the systems are cleared. They should not start with any other non-zero initial condition, because then only they will be equivalent. Otherwise, if you start with, if the flip flops are carrying some initial data, that will create error in the system outputs. So, both have to start from zeros. Okay. So, this is the proof of the retiming theorem, that every node, every edge delay you can change by adding, like if the delay is original delay is W, then W plus R of V minus R of U. V is the destination node of that edge from U to V, U is the source node for that edge, R of V is the retiming value of node V, R of U is the retiming value of the node U. So, retime delay will be W original plus R of V minus R of U, and this you do throughout the DFG. Make sure that none of the new delays becomes negative, and you get an equivalent DFG, but with new delays. Okay. This is proof of the retiming theorem. Now, we will work on its implications. Start with this. Suppose the DFG is just this, U V, there is no delay, it takes time t, it takes time t. So, critical path is t plus t 2t, because first in one cycle you have in every cycle you have to first carry out this job, take t time. In the same cycle you have to send it here, and it has to work out this job for another t cycle, then total will be 2t, then only you can send another data, and this can take another data and start working. So, that means 2t is the critical path, you cannot have clock period shorter than 2t. Now, suppose I choose the retiming value R of V. Suppose I choose 1 here, 0 here. So, new value will be original 0 plus 1 minus 0. So, it will be 1. So, a D, 1D will come up. So, this will now be pipelined, because in one cycle it does the job in t amount of time. This is required here only in the next cycle, not in the same cycle. Okay. So, t will be good enough, in one t amount of time it does the job here, then next t amount of time it works on that, and that time it prepares output for next cycle operation here. Okay. So, the two times do not get added, the pipeline you have critical path now is equal to t. Now, suppose I become greedy, I want to make the critical path still shorter, make it the system faster. So, I get inside the node, see the operations. Suppose I break the node, I am able to break the node as an example only into two nodes, sub nodes, one followed by the other. And suppose both take t by 2, t by 2, and then of course, this one So, this together is u. This also I break into two nodes, sub nodes. Again T by 2, just for example sake, and I have a delay here, this delay. Then I choose retiming value 0, 1, 1 because I want to bring a delay here. Otherwise, here they are working the same cycle. T by 2 time you spend here for my output, then give it to here. Next T by 2 time it dedicates to carry out job on that. So, total it takes T by 2 plus T by 2 T. Same here. So, if I can bring a delay here, how to bring a delay here? If I choose 0 and 1, then originally 0 plus retiming value 1, then 0. So, which is 1, so delay comes. I want to retain this delay, okay. So, I choose 1 here. So, 1 delay means 1 original plus retiming value 1 minus retiming value 1, so 1 remains 1. Then I want to have a delay here. So, already 1 here, so I choose 2. So, 0 plus 2 minus 1, so I get D. So, now the critical path is T by 2 or T by 2 or T by 2 or T by 2, so T by 2. Then you can go further break it if possible, if hardware permits this, maybe U0 prime, U0 double prime, U1 prime, U1 double prime, V0 prime, V0 double prime, V1 prime, V1 double prime, and this has a path, this has this delay, this has delay path, this has delay, like this. Again choose 0 here, 1 here, so you have a delay, 1, 1, so that 1 delay plus 1 minus 1, so 1 remains 1, so delay remains. Then you want to have a delay here, if it is 1 already, choose 2, so 0, 0 plus 2 minus 1, that means here you choose 0, 1. So, 0 plus 1 minus 0, 1. You choose 1, 1 plus 1 minus 1. So, 1 remains 1. Here there was nothing, so you choose 2. So, 0 plus 2 minus 1, a delay comes. Here already there was a delay, so no need to change, take 2. So, 1 plus 2 minus 2, 1 delay. Here I need a delay, so take it to be 3. 0 plus 3 minus 2, a delay comes. Okay. Here already I have a delay, so nothing doing, just remains 3, 0 plus 3 minus 3. Then it was 3, I need a delay here, so 4. And this way you see, now the critical path will be T by 4, T by 4, T by 4, so T by 4. So, as long as my hardware permits this kind of breaking of nodes into smaller parts, I can go on inserting delays. These delays were not in the circuit originally. Okay, these delays were not in the circuit, I am adding from external world. This is called forward path pipelining. There is only forward direction. In forward direction, I can go on retiming, I can bring in delays from outside, okay, again from outside, and the critical path reduces. This is called forward path retiming. But now I consider another structure, that is loop, and if I have to do the same thing here, we will see what happens. Suppose there is a loop, just two nodes, U, V, there cannot be a delay free loop, as I told you, because that means if you want this output, that will depend on this input, but this input depends on that same output. So, the same output eventually depends on itself, which is not possible. That is, if you call U of n, if you call V of n, U of n depends on V of n, and V of n in the same cycle depends on U of n, because there is no delay, which means U of n depends on U of n, which, as I have shown earlier, is not possible. There should be at least one delay. Take it from me, delay free loops cannot be realized. This is a delay free loop, because if it is a delay free loop, as I told you, if it is generating a signal U of n, it will depend on this V of n, but V of n will depend on E of n again. So, E of n will turn out to be function of E of n, which is not possible. But if there is a delay here, then E of n will depend on V of n minus 1, V of n minus 1 will depend on U n minus 1. So, U n will depend on U n minus 1, which is fine. So, there must be at least one delay. So, let the delay be here. Let the delay be here. Okay. And this is taking time say t, this is taking time say t, this is taking time t. So, now I become greedy like before, I break it into two sub nodes t by 2, t by 2. Okay. No, fine. So, this is now let us see the critical path here first. This path, this edge, if you forget the lower edge, just take the upper edge, there is a delay separating u and v. So, in one cycle u is taking some job, doing it in time t. This is used in this node v only in the next cycle because of the delay. So, the two times do not get added. In one cycle you do the job, next cycle that works on that. At that time this node takes some new data and prepares the output for use here in the subsequent cycle, so on and so forth. They are pipelined. So, if I had only the upper path, upper edge or upper path, critical path would have been just t, but there is a lower path, lower edge. Here there is no delay. So, first you have to carry out a job at v taking t amount of time, in the same cycle give it to u, it has to spend another t amount of time in the same cycle. So, the two times got added 2t. So, from above half, upper half critical path is t, from lower half critical path is 2t, you have to take the larger one, largest one. So, critical path here is 2t. So, to avoid that I want a delay here. Okay, to avoid that I want a delay here. How to have a delay here? If you have a retiming value 1 and 0, then what will happen? 0 delay plus 1, because this is the destination now, arrow is pointing here. So, 0 delay in this edge plus 1 minus 0. So, 1, so I will have a d. But then what happens upstairs in this edge? I have 1, now 1 plus 0, because this arrow is pointing here now for this edge. So, 1 plus 0 minus 1. So, this will go. So, lower half is now pipelined because of the delay. The two node times do not get added because they are in separate cycles. But upper half no delay. So, in one half you do first you take time t, do this job, in the same cycle give it here, it takes another time t. So, t plus t 2t. So, critical path remains 2t. Delay only has come down from upper half edge to the lower edge. So, it does not help me, the retiming here does not help me in reducing critical path at all. Okay. But you see there will be a change now. I go back to original. Suppose instead of 1d here, I had more delay. I started with, I told you delay free loop is not possible, so I took 1d, but suppose I had 2d. That the total loop delay or delay in one edge is increased now. The delay in this loop is in this edge is 2d, total delay in the loop also therefore 2d. Now, if I choose retiming value 1 here, 1 here and 0 here as before. So, here I will have 0 plus 1 minus 0, so a d will come, but upstairs what will happen? Now, I have got 2 plus 0 minus 1. So, 2d will not turn out to be 0, it will turn out to be d. So, now this is a happy situation, this edge also delayed, this edge also delayed. So, critical path will be t, which means the moment I increase the delay in an edge and therefore, total delay in the loop, then by retiming I can have better situation, I can have delay in both the edges. Okay. Now, suppose the critical path goes down. Now, suppose I become greedy, I break u into two parts, u0, u1, v also in two parts, v0, v1 as before. So, I have d here, this d, lower half d, okay, and no delays here. But t by 2, t by 2, t by 2, t by 2. I have to bring down the critical path from t to t by 2 as I did that time. Can I do that here? Okay, if we try, I want a delay here. So, start with 0 and 1 retiming values. So, 0 plus 1 because the arrow is pointing to this. So, 0 plus 1 minus 0. So, it will become d. Then this d remain as it is. I do not want any additional d. So, if it is 1, let it be 1. So, 1 plus 1 minus 1. So, 1 remains 1. Then I want a delay here. That means, if it is 1, make it 2. So, 0 plus 2 minus 1 d. But then what happens here? I have 1 plus 0 minus 2. So, which turns out to be minus d, which is not possible. Okay. So, I cannot do that. Okay. But suppose I had more delay in the loop. Suppose originally instead of 2d, I had more delay. I had say 4d. Then by choosing maybe 2 here and 0 here, I can bring in 0 plus 2 minus 0. So, 2d here and 4 plus 0 minus 2. So, 2d here. Okay. So, 2d, 2d. If I do like that, then you see you choose 0 and 1 here, you get 1. Then originally I had 2d, but 2d is not required, 1d is enough to make it delayed. For pipelining 1d is enough. So, suppose I make it 1d. What to do from 2d? If I choose 1 and if I choose 0 here, then 2 plus 0 minus 1. So, it will become just 1d. Okay, even that is enough for me. Then I need a delay here. So, it is 0. So, 2 is not required, 1 is enough for me. Okay, but originally 0 plus 1 minus 0d. And now you see I had this 2d originally here. Originally I had 2d. So, now will happen 2 plus 0 minus 1. So, 2 minus 1 it will become d. But still I am happy, every edge is delayed and processor takes is t by 2, t by 2, t by 2, t by 2. Okay, so, critical path is t by 2. But for this I had to increase the delay, loop delay, or rather delay in one edge, and therefore total delay in the loop from 2d to 4d. Otherwise I could not. But if you go to the previous page, you see originally I had nothing, then I could happily put a delay here, then I broke into 2 parts, I could happily put new delay from outside world, and I could go on doing it. I never had this problem of changing the delay value of the original edge. So, this is the problem of retiming a loop. In retiming a loop, your freedom is limited. Depending on the original loop delay, you can go only up to some extent, not beyond that. So, this has a fundamental origin which we will discuss in the next class. Thank you very much.